Have you ever wondered how many times a machine might fail before it produces a certain number of items? Or perhaps how many times a gambler needs to roll a dice before landing a 6? Welcome to the world of negative binomial distribution. In the realm of probability theory and statistics, a discrete probability distribution, known as the negative binomial distribution, provides answers to such intriguing questions. It models the number of failures in a sequence of independent and identically distributed Bernoulli trials before a specified number of successes occurs. This distribution is defined by two parameters. First, we have R, which represents the number of successes that must occur before the sequence ends. Second, there's P, the probability of a success on each trial. The probability mass function, or PMF, of the negative binomial distribution is expressed with the formula px equals k plus r minus 1 factorial divided by times p raised to the power r times 1 minus p raised to the power k. Here, k is a non-negative integer. The mean and variance of the negative binomial distribution are also calculable. The mean, denoted by the Greek letter mu, is equal to er times p divided by 1 minus p. The variance, denoted by sigma squared, is equal to r times 1 minus p divided by 1 minus p squared. Interestingly, the negative binomial distribution is a special case of the gamma distribution, a more general distribution that can model a wider variety of random variables. Now, let's delve into some real-world applications. This distribution can be used to model the number of times a machine fails before it produces k items. For instance, if a machine has a 1% chance of failing on each item it produces, the negative binomial distribution can predict the number of items needed to produce EA items before the machine fails. Another classic example is a gambler rolling a dice before getting a 6. If a gambler rolls a 6-sided dice, this distribution can model the number of rolls it takes to get a 6. In a business setting, consider a customer calling a customer service center before they get a representative. If a customer service center has a 90% chance of answering the phone on the first ring, this distribution can model the number of times a customer needs to call before they get a representative. In conclusion, the negative binomial distribution is a versatile and useful tool for modeling a variety of random variables. It's a simple and easy-to-use distribution, often employed in applied probability and statistics. It's a fascinating concept that brings a sense of predictability to a world filled with randomness.